Hi, today we will explain the insulation resistance test of a transformer. The insulation resistance test of a transformer is carried out to test the integrity of the winding insulation of the transformer. Better insulation means that there will be lower current leakages and better safety. What is the purpose of insulation resistance test? Well, the purpose of this test is to detect major faults of major insulations of a transformer. So what is the major insulation and major faults in a transformer? Major insulations in a transformer are: number 1, insulation between HV and LV windings; number 2, insulation between HV and ground; and number 3, insulation between LV and ground. And major faults in a transformer are: number 1, insulation failure between HV and LV windings; number 2, insulation failure between HV and ground; and number 3, insulation failure between LV winding and ground. When to perform this test? Well, insulation resistance test is performed on a transformer when the transformer is newly installed or the transformer is under fault. Now we explain the procedure of insulation resistance test of a transformer. First of all, isolate and de-energize the transformer. Then short all the HV windings and neutral if any together. Then short all the LV windings and neutral together. Note the oil temperature because the insulation resistance value is highly dependent on temperature, and insulation resistance readings are corrected to 20 degrees Celsius temperature. For a 2-winding transformer, we take 3 readings, that is H-XG, X-HG and HX-G. So what does it mean? H means HV windings, X means LV windings and G means ground. So H-XG means that we connect LV windings and ground together and consider them as a single point. The testing set that is used to measure the insulation resistance of a transformer is called the Megger set. So we connect one lead of Megger set with HV windings and another lead to LV windings. X-HG means that we connect HV winding and ground together and consider that as a single point. Then we connect one lead of Megger set to LV windings and another to HV windings. Similarly, HX-G means that we connect HV and LV windings together and consider that as a single point. Then we connect one lead of Megger to this single point and another lead to the ground. We come across the interpretation of the results that we obtained from these tests. For satisfactory insulation, the insulation resistance value must be at least 1 mega ohm for every 1 kilovolt. If we have a 500/220 kV transformer, the insulation resistance value on HV side must be at least 500 mega ohm and on LV side it must be at least 220 mega ohm. But all these results must be corrected to a standard temperature of 20 degrees Celsius. The insulation resistance value is highly dependent on temperature. The value of insulation resistance doubles for every 10 degrees Celsius drop in temperature. So, if the insulation resistance is 100 mega ohm at 30 degrees Celsius, its value will be 200 mega ohm at 20 degrees Celsius. Now, we will explain this with an example. Suppose we have a room temperature of 30 degrees Celsius and suppose we get the following 3 readings for a 500/220 kV transformer. Now, as we know that the value of insulation resistance doubles for every 10 degrees Celsius drop in temperature, so let's convert these values to standard temperature of 20 degrees Celsius. So all of these values will become double at 20 degrees Celsius temperature and we get the following values. Now for a 500/220 kV transformer, on HV side the insulation resistance value must be at least 500 mega ohm. Here we have IR is equal to 800 mega ohm, which is satisfactory. For LV side the IR value must be at least 220 mega ohm. Here we have 600 mega ohm, which is also fine. Similarly, we have IR is equal to 1000 mega ohm between HV, LV and ground, which is also satisfactory. Now we further break down the results and do a detailed analysis. From the first reading we conclude that H-X is good and HG is also good. It means that the insulation between HV winding and LV winding is good, and also the insulation between HV winding and ground is good. From the second reading we conclude that XH is good and XG is good, which means that the insulation between LV and HV windings is good and the insulation between LV winding and ground is also good. From the third result, we conclude that HG is good and XG is good, which means that the insulation between HV winding and ground is good and the insulation between LV winding and ground is good. So, overall the insulation resistance of this transformer is satisfactory and safe. Now let's discuss another example. Suppose we have a 66/11 kV transformer and the room temperature is 35 degrees Celsius and we get the following readings from the insulation resistance test. Now let's correct these values at a standard temperature of 20 degrees Celsius. Now in this specific case, to calculate the values at 20 degrees Celsius, first we will calculate the values at 25 degrees Celsius and after that we calculate the values at 15 degrees Celsius. After both the readings are obtained, we will take the average and we have the required values at 20 degrees Celsius. After the necessary calculations, we obtain the following three values. Now as we can see from the value that the first value is 150 mega ohm, which is satisfactory because the required value is 66 mega ohm. But if we look at the second and third values, these are not satisfactory because they are lower than the required value of 11 mega ohm. Now from the first reading we conclude that HX is good and HG is also good, which means that the insulation between HV and LV windings is good and also the insulation between HV and ground is good. From the second reading, we conclude that HX is poor and XG is also poor. And from the third reading, we obtain that HG is poor and XG is also poor. Now, we will consider a value as good or poor if it's repeated twice. For example, one reading of a value is good and another reading of the same value is poor, then we will take it as good. And if we have both values as poor, it will be considered as poor. Now in this specific case, we can see that XG is poor twice. So the insulation between LV winding and ground is poor, or there is a short circuit between LV winding and ground. This gives us an alarm that we must carry out the required maintenance to avoid any damage. Thanks for watching the video. Subscribe our channel for more videos and feel free to ask any question in the comment section.